Well, hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin and today we are gonna solve the last lab of web cache deception vulnerability module. The difficulty level of this lab is expert because that's gonna be much more difficult than the previous labs. So in this lab, we are gonna see exploiting the exact match cache rules for web cache deception. That means we need to find out the exact cache rule, okay, configured on the cache server. We need to find out that exact match of the cache rule, and then we will find out the discrepancies and we will exploit the web cache deception vulnerability. So the description of this lab is saying, to solve the lab, change the email address of the user administrator. You can log into your own account using the following credential, which is Wiener, and the password is Peter. So after solving this lab, you will realize that this vulnerability could be very severe or could be very harmful for any organization. And if the application contains this kind of vulnerability, it is gonna be very severe. So it's saying that this lab also contains the word list for the delimiter characters, and I will use seklist delimiter special character list. Okay, so without wasting time, I'm just going to jump to the lab by clicking on access the lab, which I already did here, and this is our lab. So without wasting time, I'm just gonna click on my account to log in. So here we are, Wiener, and the password is Peter. Log in, don't save. So we logged in successfully. Back to the burp suite to analyze the request. This is our login request, post request for login, and this is the my account page. Fine. Everything looks perfect, and here you can see there is no indication for the cache mechanism. So let's analyze the request, like /resource/js/tracking.js seems like the traditional URL. And here also, in the previous labs, most of the time you see in this request you see the cache mechanism in place, but this time we don't see this. Okay, here also, so in any request we do not find any cache mechanism in place or any cache response header, so that we know that cache mechanism in place. So what we will do now, okay, the lab is asking for change email of the administrator user. So let's go and we will try to change the email address by saying test1 at cybersec.radar. Okay, let's update the email, and email is updated now. Back to the burp proxy. This is the post request, this one, post request for changing the email address. And if you see this request closely, one interesting part here is CSRF token. Okay, in the previous request, once we log in, you can see here also we have CSRF token, and in this request where we change the email address, we also have CSRF token. So in each request we have CSRF token for changing the email, for login and all. Okay, so we will also try to find out if there is vulnerability in the application for the CSRF, cross-site request forgery, because as you can see here, we don't have any API token, and also the lab is asking for changing the email address of the administrator user. So this solution may contain CSRF also, because if you already watched the CSRF module, you will know that how you can try CSRF to change the email address of the victim user. And also here we have the exploit server. Fine. So let's see. First of all, I'm going to send this request, which is my account, this one, and let's send this to the repeater, and we will try to find out first of all the path mapping discrepancies /AAA and send the request again. Just before sending that, I want to make sure that I'm getting the response correctly. So you can see we have here the response headers. There is no sign of any cache, and this is the response. And in the response, if you see, you can see this is our dashboard page. And if you see the form, you will find out two input fields are there. The first one is email, and the second one, the input field, this field is hidden, and that field contains the CSRF token. So if somehow we can get the CSRF token of the administrator user, then we will be easily able to trick that user by sending a malicious link that contains the CSRF token for the administrator user. We will successfully change the email of the administrator user account. But how we will get the CSRF token of the administrator account? And this is gonna be very similar what we did in the previous labs, as we collected the API key of the victim user. So similarly, if we successfully cache this response in the cache, which is not here, but if somehow by finding the cache mechanism in place, by finding some kind of discrepancies, and by exploiting those discrepancies between the cache server and the origin server, if somehow we can store this response within the cache, and we can exfiltrate the CSRF token of the administrator or any victim user. So for that purpose, we need to find out the discrepancies. But the thing here is we don't know whether cache mechanism is in place or not, because in all these previous requests we analyze one by one, but we do not find in any request, we do not find any response header that shows or indicate us for the cache. So let's see, back to the repeater, and let's say AAA, send this. So you can see no cache response header, and there is no response because the origin server cannot abstract this path my account. Fine. Second thing, we can try a bunch of file extension, because we saw before there are some .js file extension, although we do not even find here any response header related to cache, but still you can test this. So no, let's see .text, nothing, .asp or aspx, .php, .html, whatever you can try, we need to try everything. So nothing here. Okay, so first thing is very important for us to find out whether the cache mechanism is in place or not. Okay, second thing what we can try the delimiter characters, maybe some kind of delimiter characters used by the origin server. So we need to brute force this, and for this purpose I'm gonna just right click on this request in the repeater and send it to the intruder. Back to the intruder, clear all the payload positions, and here just highlight this one and add it. Make sure the attack type is sniper. Payload, I'm gonna load the list within the, you can see here, /user share seclist, and fuzzing, within the fuzzing directory we have here special characters. Fine. So everything we already have here. Make sure the URL encode characters, this one must be unchecked, and start the attack. And as you can see, all the response code or status code, we have 404. There is 1, 200, 200. So I'm just gonna filter out this result in the ascending order, and you can see these two special characters are used as delimiter characters by the origin server. So you can see if I choose this, it comes like this, and if we see the response, this time you can see the origin server can provide us the response. Okay, so if I try CSRF, you can see there is CSRF. Fine, but there is no indication of the cache. Similarly, if you go to question mark and you see the request, this part of the URL will be treated as the query string. So the origin server can abstract this path, fine. And in the response, you can see we have the response, but there is no indication of the cache. So I'm gonna close this one. We don't need that. Back to the repeater, and we can try this here. So question mark, and you can see this time instead of not found, we get the response, but no cache. Similarly, if we try this semicolon, okay, fine. So this is the thing, we get the response, but still we get the response, we find out the delimiter characters, but still no cache mechanism in place. Second thing, what I can try is go back to the proxy, and we can try, because in the cache there may be a rule that belongs to the exact directory, or maybe that belongs to the exact some specific file with some specific file extension. So we already tried this one. Let's see tracking.js. We do not write here tracking.js. Still no sign of cache. We can also try something else. Let's say /resources, and you can see not found because of this one. If we try question mark, even though we do not find the cache mechanism in place, we just get the response. Next thing, we can try this one. Again, no cache. So what else we can try? You can see there is no mean to get the cache, but it doesn't mean the cache is not there. So there are still some thing left, which is what we need to find out, because the lab is saying we need to find out the exact match of the cache rules. So the exact match means there could be a specific directory name which is specified in the cache rules, or maybe there is some specific file name, although we try here bunch of file extension, but it doesn't mean that only this file extension, by this file extension we can get the response header related to cache, because maybe in the cache rule only some specific files are configured in the cache rule. So for this purpose, what I'm going to do, I'm going to create one Python file, okay, and we will execute it to just enumerate the files. Okay, so I'm gonna put the environment variable here, user bin env python 3. Then I'm gonna import some modules. Let's say request import url lib3, and then url lib3 dot disable underscore warnings. And then let's say I want, once I execute this file to enumerate the file name, I want all these requests go through the burp proxy. So we need to define proxies is equal to so HTTP proxy is gonna be http://127 localhost, and the port number is 8080. If you use some different port on your burp proxy, so make sure you put that port. On the place of HTTPS, I'm just using HTTP proxy, so I'm gonna define that only, not HTTPS. Fine. Next thing, we need to define the URL. So let's say the URL here is, I'm gonna take this URL, copy URL and paste it here. And I don't need this right now, okay, just this. And let's say the file name, come on, what's going on? Okay, file is equal to user share word list, not word list. Let's say I'm gonna use word list for the file names with different extension with the sec list, and within the sec list there is a directory named as discovery, and within that there is web content, I think in the uppercase C, and there is a file name named as raft. Let's see, go here, file system, user share sec list, within sec list discovery web contents, and within web contents we have raft, not directories. I'm looking for file. This is the large one, we need the small one. Raft small file, this one. Okay, so this is the path, and the file name is raft small file.txt. It's, I think, files. Yeah, files.txt. So this is gonna be the file name. Okay, and then let's create one definition. Definition is enum, to enumerate. We don't need any argument. Now we need to access this file by saying with open file, which we already define here by the name file, and we need to just read this file, and we need to save the output of this file as out file, or you can name it as you want. Okay, let's say I'm gonna save this result as the variable name results, and I'm gonna say out file dot read. Okay, and I'm gonna split on every line. So this is regular expression. Okay, that's it. And then I'm going to run here one loop, for loop, and within this for loop I'm going to say for result in results. Okay, within this every line will take one by one within from this variable, whatever the result saved in this variable, I'm going to take it one by one, and we're gonna generate one request. So request dot get URL is equal to URL comma also URL actually plus result. So from this result it will take the first file name and put it within the URL. So this is the URL. Okay, and after slash it will put that file name. Okay, and let's say verify is equal to false. It's necessary because we need to avoid the SSL certificate verification, and proxies is equal to proxies. Okay, now we already make the request. Now we need to see the response. So we will save the response as r.text. Okay, and this is r.text is for the complete response, but we are actually gonna see whether the response contains the cache header or not. So I'm not interested in the complete response. I'm interested in headers. So it will take the it will generate the request, and within the response it will only see the headers, response headers. Okay, now what I'm gonna do is I'm gonna check if X cache header is there in the response, which is this. Okay, so what it's gonna do, it's gonna print, and print what? Print, let's say plus found cache response in header let's say plus, and again within the double quote I'm gonna type here like this. Okay, so the first one is up to here, then plus just wait a moment, we missed something, result, because we need to also put the value so that you know which file name contains this response header, and this result is actually this one. Okay, this variable. So I think that's pretty fine. We just need to call this definition, which is named as enum. That's it. Save, and within the desktop I'm gonna save it as file enum.py, file enumeration.py. Let's see, just refresh this one more time. Maybe the lab is still alive. Fine, so everything is done. We just need to open the terminal, cd desktop, and python 3 file enum.py. Hit enter. Hopefully it will work, and if it's work, we will find out here the requests are. So you can see it will take one by one all the files from the raft small file.txt word file, and then check one by one each and every file. Okay, so any file that contains the X cache response header, it is gonna detect here. Okay, and give us the file name. Okay, fine. You can see we get one file name, which is favicon.ico. And if we go back here, let it work. Let's see, if we go to the repeater and copy selection back to the repeater, if we put this, take out actually everything from here, just favicon.ico. And as you can see, X cache header is there. That means cache is in place, but specifically the cache rule is specifically for this file name with the extension. So even if I change just the file name but keep the extension same as it is, you will see we do not get here any cache header, response header for the X cache. So that means this is the exact rule for the cache. Fine, wonderful. But the problem here is you can see, because this is the favicon, so some kind of gibberish here. Okay, let's try my account. Okay, and slash. So you can see no cache indication, also there is no response. So instead of that, because we know that the origin server is using this delimiter, so let's send this again. So you can see we have the response, but we don't have any cache indication. What we can try is, let's say something like this, to put the path traversal. Still there is no sign of cache, but we have the response. So I'm going to select this and URL encode it. Try one more time. Nope. Let's try to, oh come on, let's try to also URL encode this question mark. Okay, now you can see once we try to URL encode this question mark sign, we do not have now the response from the server. Okay, so what else we can do? We know that there are two delimiters, right? First one is question mark, second one is semicolon. So let's try semicolon. And wonderful, this time you can see we have cache in place and we also have this response. If we send this request one more time, you can see this time we get hit. So that means this response is now we get from the cache, because this response is already stored in the cache. So we are good to go. You can see we have the CSRF. Let's see the result of this one. And you can also see that there is one more cache rule with the exact file name, which is robots.txt. Okay, so I think that's enough. I'm gonna just Control C. So we have two file names, favicon.ico and robot.txt. So let's try here robots.txt. Send this one more time. Wonderful. So that means now the cache is able to URL decode of this path traversal ... /. That means it is able to decode this ... / section what we put here. Okay, and this is what we need to send to the victim. Fine. So let's see. What I'm gonna do here now is go to the exploit server and let's see, script document dot location is equal to close the script tag / script. Okay, back here, just I'm gonna copy the URL because this URL we need to send to the victim. Fine. So store this exploit. Why we are sending this malicious link to the victim? Because we want that once the victim access this URL, the victim's response of this page, dashboard page, will be cached or stored in the cache server. And we will again, once the victim access that URL, we will go to the repeater and we will try to access the same malicious URL so that we can fetch the response directly from the cache for the victim user. And in that way, we will get the CSRF token of the victim user. And once we get the CSRF token of the victim user, that's it. That means we can change the email address of the victim user by CSRF exploit. Okay, so let's go. Everything seems perfect. Store the exploit and deliver this to the victim. Okay, go to the access log and let's see the victim access our malicious link or not. So you can see he tried to access. Back here, without wasting time, just send the same. You can see we get the hit. That means first time once the victim access this URL link, malicious link, he will get the miss here, but the response, which is this response, is stored in the cache. And the second time once we send this request with the malicious link, same as what we sent to the victim, we get this response from the cache. So you can see the username is administrator. This means this response is the welcome page or dashboard page for the administrator, and you can see this is the CSRF token for the administrator. Fine. So I'm gonna copy this back here. Paste that. So you can see if I go back and try to CSRF, you can see this was our CSRF token. Winner, and this is the CSRF token for the administrator. Okay. Now, once we get the CSRF token of the administrator, now we can try CSRF exploit to change the email address of the administrator. So let's go back to the exploit server, and we are gonna create the exploit for actually okay. So we need to create one form. Okay, and action is equal to, we need to put here the URL for the change email functionality, and method we will use the post, because we saw before once we try to change our email, the method used was post. Fine. So this is the first thing. Second thing, within the form field we need to use input tags. So input tag type is gonna be hidden because we don't want user see what he is submitting. Name of the field is email, and let's say the value of the field, value of that email field is gonna be let's say hacked at cybersec.radar. Okay. Second thing, we need to copy paste that here. Oh, come on. Paste that here. Second field was CSRF, right? And the CSRF token value for the administrator, we already have it here. So I'm gonna copy that and paste it here. That's it. We need to close the form tag, and within the script, document dot forms, and because we only have one form, so the index value is 0, and we need to submit this form. That's it. Fine. We just need to put the URL here. So come back here. If we go to the proxy, because we need to go really scroll down to the last, here we have change email. This is the change email. Yeah, copy the URL back to the exploit server, paste that. Fine. Hope for the best. Although we won't be able to see the changed email of the administrator, but if the administrator access that page which we are gonna publish on our exploit server, so if the administrator user or victim user access our exploit server published page, and because he is already logged in, so the session cookie he already has, and the CSRF token we are feeding here, which we get from the by exploiting the web cache deception, we are gonna submit this form. So store this. Hope for the best, deliver exploit to the victim. I think everything I did here is perfect, and I do not make any mistake, and yes, we do not make any mistake. So congratulations, you solved the lab, and we solved the lab successfully. That means the email address of the administrator successfully changed. Although I missed one part, I could have tried this by saying view exploit. We can do this by saying, let's say hack, and instead of administrator's CSRF token, if we put here our CSRF token, copy and paste it here, and if we go for the view exploit, so our email should be changed. Right now our email is test1, but if we view exploit means we are trying to access the exploit server page to check the CSRF is working or not, and you can see our email address gets changed. And the similar way, the email address of the administrator user or the victim user gets changed. So that's it for this lab. Hope you like the content. If you like the content, please like, subscribe and share, and I'm gonna see you in the next module. Bye.